And I want to give a few answers today to the question how LLMs might change academic work, might change academic practice, and maybe also the science system at large. I was told that I should talk no longer than 40 minutes to leave room for discussions, and I will do my best to do so. I want to start with two questions to the audience. So please use the raise your hand function of Zoom. If you have ever used ChatGPT or any other LLM-based chatbots. Okay, 55 and counting. I would be a little surprised if it's not basically everyone, or at least those who okay, 80. Okay, yeah. I think most of you have done this. Thank you. And maybe you can answer now the question whether you have used them in your academic work. So not for playing around, for experimenting, but for, you know, for your work. Oh, approximately 70. So approximately half of the people in this lecture. Cool. Then I think we have something to talk about. And I hope I can still share something new with you. What I'm presenting to you today is largely based on findings of a study on large language models and their impact on science and the scientific system, which a few colleagues of mine and I conducted at the beginning of last year, exactly on the question what impact LLMs might have on scientific practice and the science system. The final article has been published in AI in Society in October last year, and it is, of course, openly available. There's a, the image has moved. It's open access. There's a QR code, and you can make a photo and download it. Otherwise, you will see that. You can also use the DOI. What I'm going to do today is I give a little bit of background on LLMs and the discussions around that. I say something about what our research interests are, what methods we used, and what the results are. That is what came from the scientists, the researchers we asked. And I will try to answer the question both with regard to what the scientists said, but also what other discussions are around, what other transformations, developments in this field are around, or whether science is transforming, that is in a positive way, or there's a deformation of science that is a negative way. LLMs have a very long history. The first, at least the first neurons were proposed in 1943. They're part of the very well-known boom and bust cycle in AI. The bust cycle, you know, always called AI winter. We had a couple of those. Maybe we have one in the future again, or a couple of them. There are different approaches to if you want to try to implement AI systems, the symbolic, or the most important are the symbolic and the sub-symbolic approach. And LLMs are part of the sub-symbolic approach. The main difference is that this symbolic approach is based on explicit knowledge representation, inference rules and logics. And that means, and that's why it's important to look at the history, that means that connectionist approaches or subsymbolic approaches produce kind of machines where we cannot say for sure what knowledge is represented in them, or more colloquially, what they really know and what they really don't know. There is a second thing in there is then they're kind of an example of a technology that is not really new, that has long been there, both in theory and practice, at least on a smaller scale, but only recently gained widespread attention. Only when the first very impressive applications emerged on the market, also within academic cycles. And that means that there already have been both academic discussions and public debates at earlier stages of this development, even though they're sometimes overlooked or forgotten. And they had and still have an influence on what our expectations are today, both positive and negative. So our dreams and our fears. And that influences also the answers of the question of the scientists that we asked in our study. Something on the background with regards to the discourse on ChatGPT and LLMs in general. The release of ChatGPT in 2022, late 2022, has sparked wild speculation on what we might see in the future and what impact that might have on all parts of society, but what we're interested here now, especially on the science system. When you follow the discourse, it becomes apparent that there's practically nothing where scholars don't see a potential applications for these systems. This hints at the possibility that this technology could significantly alter scientific practices, academia, and maybe also the relationship between us as scientists and science as a system and the public. However, many see that LLMs, at least at that time, may produce plausible, but more often than not, nonsensical results, unoriginal text, and that they were incredibly intransparent about the training data and unreproducible with regards to the outcome. We can therefore conclude, at least at the moment, we're dealing with a multitude of speculations and do not precisely know how LLMs will impact science and, of course, society at large. And that's why we think we need to organize and assess the potential implications. That's what sparked our research interest. And with this study, we wanted to get the first assessment of the potential impact of LLMs on science and scientific practice, to consolidate a bit the plethora of opinions that are out there. In particular, we asked about the potential applications of LLMs and the limitations that researchers see, and the risks and opportunities on the science system, but also on individual scholarly practices. We also focused on what are the competencies, or what the researchers see as competencies that are necessary for effectively utilizing LLMs. And we explored the potential ethical and legal considerations that they came forward with. What we did is a two-step Delphi process. Delphi is a method, not really an empirical method, but an assessment method with regards to opinions that are out there in some field, a multi-stage survey method that looks at what a panel of experts say to some issue or some development. And it is a method that tries to establish something like consensus among a group of experts on some issue. And it may be used to forecast, assess, or evaluate what's out there and what might come in the future. What we did is a two-stage or two-round Delphi process. We used 2 rounds, the first one containing largely open questions on our major research interest, and we analyzed the answers using a structuring content analysis. And the second survey was then based on that, and contained largely closed questions and ranking questions that we then analyzed statistically. For those interested, the data is available, open access online on the same page as the article, so you can play around, but it might also be a very good historical account of what experts thought in the beginning of the year 2023 about the impacts of LLM on science. A bit on the statistics or the outcome. We had 72 responses, then 72 experts in the first round, and a bit less in the second round. You see information on the sociodemographics of the researchers that answered. So many with the background in math and computer science, but all of them working basically on issues around technology and society. So they're not kind of pure mathematicians or kind of single-minded computer scientists. It is very non-representative with regards to the size and with regards to the demographics. And I think that's important to keep in mind, especially when we then try to interpret the statistical results. Importantly, the data collection period was early 2023, from February to May, and the final article was then published in October. So what do the experts predict on all of the questions that we had? So what do they see with regards to the applications and limitations of use? In the first round, we straightforward and openly asked the experts where they see potential fields of applications in scientific work. And what you can see is that they identified especially things around text, text improvement, text summarization, and that might not be surprising because that's a very important part of scholarly work. Additionally, many experts may be influenced by the presence of so many computer scientists, and our sample also use LLMs for programming or around programming. It might not be the programming task itself, but something like to make sense of the error messages or to identify bugs in code. Most of our respondents already use LLMs in their work. I think we have seen that the numbers are higher today. Among our experts, it was about 60%. And I think it will be more today. The limitations mentioned can be essentially explained by the data sets that existing LLMs were trained on. For many, maybe also for many of you who have worked with ChatGPT, there might have been a quick disillusionment after the initial excitement. The program or the system often generates plausible but generic and outdated nonsense in an intransparent manner. And this diminishes the utility for many researchers because they're not exactly hallmarks of good scientific practice. Nonsense, outdated, and possibly incorrect. One of the respondents said, I've played with ChatGPT a lot recently, and I've tried to ask it to perform various scientific tasks of different complexities. For example, explaining in plain words a very complicated scientific topic, or conversely, explaining it in a very sciencey way, including equations and references to corroborate explanations. If on one hand, it performed remarkably well in simplifying hard science into plain words, often naively, but that's okay, it performed really poorly when explaining a topic in detail, providing the wrong, incorrect, incomplete set of equations, as well as making up references. That's most probably something that you have already heard about these systems. So what are then the opportunities and risks for the science system? Speaking of generic and plausible nonsense, the experts see considerable potential in automating administrative workload. Given that the increasing burden of academic bureaucracy has become worse and worse, at least if measured by the average time researchers spend on administrative tasks, LLM could be possibly a game changer. So just envision a world without project reports. And maybe that's one of the great potentials for LLMs. Furthermore, we found it interesting that many perceive an inclusivity aspect in LLMs as they level the playing field for researchers who come from non-English speaking countries or have limited support staff. Unfortunately, there's also a downside in this regard. Elizabeth Wolkowicz, Associate Professor of Forest and Conservation Sciences at the University of British Columbia in Vancouver, Canada, has just published a story in Nature on how reviewers accused her of scientific fraud because her work was deemed that her contribution was, quote, obviously ChatGPT, unquote. She found it hard to react on this, and she found it especially hard to prove that it was not ChatGPT, but herself who wrote the text. There were also some who saw benefits for creativity and reflexive work, but that was a minor aspect compared to the productivity and the time-saving hopes. Keep in mind, though, that this assessment is influenced by the development stage of accessible LLMs and the experts' experience up to the time of the survey. One must not underestimate the risks as they touch the very foundations of academic work. Many experts argue that LLMs cause biases by perpetuating majority opinions and stereotypes. They can produce text on a large scale that sounds scholarly, but in the mildest case is nonsensical, and in the worst case, propaganda. That's for the reason they have been called stochastic parrots. And lastly, according to many experts, the scientific quality assurance system, the peer review, could collapse under the burden of automatically generated texts. Also, although there are already quite effective policies in journals and unfortunately not so good detection software. And that's one of the problems because many of these detection software systems out there seem to work in a way that actually they identify non-native speakers and ChatGPT output in a similar way. That is because the LLM-based systems also produce lots of text with phrases, ever recurring phrases, something that maybe also non-natives do. at least they found it hard. There was an experiment, and they found it hard to distinguish LLM-generated text from non-native speakers generated text, at least with the detection software. What do people think what the necessary competencies are? There's an echo. Can someone please? Okay, thank you. No? There's still an echo. Okay. What competencies?
Could everybody mute themselves? Sorry for interrupting, Jörg, but I think
Yeah.
somebody may be unmuted. That's what they're calling the echo. So if everybody could watch out that they're muted, that would be perfect. Thank you.
Thank you. One of the competencies then the researchers we asked see as required reflexivity. So thinking about what you're doing, your ability to contextualize the results that come out of the machine to the field that you're working in, and that might not be a real good fit. It might just be a kind of statistical fit, if you will. There was a large part, and also said an ethical understanding is necessary, especially academic ethics, in the sense of what do we require academics to do and how to behave, the transparent way of doing things, and doing things in a way that can be reproduced by others. And it might be a bit surprising that so many people said things other than technical know-how as a most important aspect or the most important competence that they think is required to work with those systems. One of the respondents said they have to understand how the LLMs work, how the responses are generated, and have to be willing to verify all the facts that pop up. Not just take good sounding text at face value. They will have to understand how the biases will be affecting the results, cementing the past without giving a chance to new ways of thinking. And last but not least, we've looked into what researchers in this field, in the field of technology and society, think about the ethical and legal implications. And it might not be a surprise to any of you that a majority of them thinks that LLMs should be stronger regulated. In contrast to the other topics, we did not ask the experts in the second round to rank the ethical and legal implications, and that's why no bars and no numbers. Instead, we looked at what they came up with only in the first round. So those are the main results, and then let's move to what they think about the question of whether there's a transformation in a positive way or a deformation in that is a negative way of the scientific system and of scientific practice in due to these systems and their use. Despite the gravity of the aforementioned risks, the majority of our experts in our study perceive the advantages of LLMs to outweigh the disadvantages. We must, however, consider this result against a backdrop that our expert selection is a particular one, with researchers studying technology and society. Nevertheless, I think this assessment is noteworthy. Almost 50% of about 50% agreed or strongly agreed with this, compared to only 23% who disagreed. Those are the numbers, not the percentages here. And 23% disagreement is not that big. With regards to the question of we get all replaced by those systems and the robots will take over science, that's not what the researchers in this field see. It's not only the case that most of them already use them, but they also, a majority of them thinks, more than 80%, thinks that LLM will not replace researchers in practice. I don't think, as one of them said, the use of AI in academia will replace scientists. It will change their working routine, but in a way as the invention of telephones, computers, printers, and other technological artifacts have also changed academia without making it obsolete. So looking at what all the researchers in our survey came up with, we think we can bring that together as, you know, there's this utopian transformative scenario that looks like that LLM based systems and their use with streamline tasks that we consider repetitive, especially if they're not, if they're more about bureaucratic work than academic work, even though we do them as academics in practice a lot. Those systems might promote inclusivity because they allow for people to take part in science and publish their results in an easier way, even if they're not native speakers. And they might also find it easier to find information and to make sense of what they then read. And it might help in facilitating interdisciplinary research. On the other hand, there might also be dystopian aspects in there. And one of the key aspects of that might be a decline in research quality that we might see, or research diversity, because everything is, you know, going ever more mainstream in the same way as LLMs are actually working, which is a big kind of majority issue. So they will always come to this kind of mainstream point, and or the long tail in science might go away in some way at least, and it might decrease scientific integrity because we don't know where the results come from. We don't know how they came together, and we cannot reproduce them. At least one of them, and we translated that because the original answer was in German. I harbor the hope that this will put a stop to the flood of publications, because if mediocre articles can be written by software in the future, this achievement will lose its already low information value. That's something to hope for. I'm not really sure about that. Because, and that's one of the things that we have to keep in mind, there is already an increasing datafication and quantification in the way we do assess and evaluate individual researchers, but also the institutions they work for. And that has an influence on not only how we evaluate them, but for how we treat them afterwards, especially with regards to their careers. But it also has an influence on how the science system as such in general behaves, and what kind of research is done in the future, and maybe also where the funding goes. This is the abundance found in Rome, Trevi di Roma. So the abundance is then kind of channeled to those who already have, or to those who are better in using LLM-based systems for their work. And that's the main question then, is what do we measure, and is that the right thing? isn't done what we measure today. Actually, the very things that, or the very aspects that LLM-based systems and other automation technologies may actually replace, isn't done, don't we measure productivity, which is something that actually those systems help us with. And maybe it would be better to measure, or to assess at least, I mean, not measure, but assess qualitative factors such as creativity, originality, or the question of, whether scientists come up with a dissenting opinion on something, or a new idea, or another idea, or they disagree with something that's already out there. And that might be much more important for us in academia, in science, but also for society. And that means that the question would be is, what would be, how would we think about what the mission is of academics in the future, that we want to value and that we want to appreciate, and thus want to take into account when we, for example, make decisions about funding or about careers. And one of the problems that I might see in LLM-based systems, but also other automation technologies, is that they actually reinforce and amplify the quantification, the drive towards quantification in the assessment of scientific output and the scientific quality and the quality of researchers. And that might not be a good thing. And the second, which I think is something which I already think about for a very long time, is what we see in academia is that a large part of that is still very much artisanal. So in some way, it's still medieval. We do lots of manual work in academic research. And the question is, wouldn't those systems at least require us to ask whether there are other ways of doing research, for example, in order to tackle the grand challenges that Stephanie was also talking about in her introduction, that we can move from basically handcraft to industrial production of knowledge. And the question is, how would that look like? But I could imagine that as we see that so much scholarly work is already out there, then without kind of technological support or automated systems, it's highly improbable that individual researchers or even small groups can have an understanding of what a field looks like, or what a meaningful direction of a field is looking like, and being able to question that. And it might also be a way of fostering kind of real interdisciplinarity or transdisciplinarity, and not the kind of token interdisciplinarity that we see today. And in many instances, then, something like each discipline writes one section of a paper that is then sold as an interdisciplinary work. But in reality, they have not really interfered with each other, and they have not really interacted so to come up with something new that is at the intersection of the disciplines and not only at the boundaries of them. So how to close that and how to look forward, and maybe also then how to look to the discussion afterwards that we can have. I think a quote by one of the responders is maybe the best way to close this. I think there will be a rapid process of experimentation and then adaptation happening in a lot of fields and across society. Different people, including academics, will discover where the tool works well and can aid us. There will be areas where it will fool us and we need warnings not to trust in. And I also foresee a lot of potential for abusive use cases. We will adapt with new norms and rules. And in my opinion, the more people understand the technology, the smoother we can adapt. A responsible use of LLMs in scientific practice also necessitates training and education, as well as experimentation. I think, as it is often the case with new technologies that come our way, they're not a force of nature, but rather development that we can control and that we should control. And that's up to us how we do that. Many thanks